This watermelon was at rest. It wanted to remain at rest, but it was acted on by an unbalanced force. What does that mean? Isaac Newton is one of the most famous scientists in history. He lived in England over 300 years ago, but his ideas about motion and gravity still hold true today. Today we'll learn about Newton's first law of motion. By the way, most people believe he was never really hit on the head by an apple. Newton's first law of motion states that an object at rest will stay at rest and an object in motion will stay in motion unless acted on by an unbalanced force. So whatever the water balloon is attached to provides an upward force. Gravity is a downward force. The balloon is still because these two forces are balanced. It's at rest. But what happens when the dart hits it? Suddenly the forces are not in balance anymore. The upward force disappears and the only significant force left is gravity, so the water begins to fall. The forces are unbalanced. When forces are unbalanced, things begin to move. These marbles are bouncing and spinning because the forces acting on them are unbalanced. My dog Nelson doesn't move much. When he's still, the forces acting on him are balanced, but when he sees food, suddenly his forces become unbalanced. Newton's first law of motion is also called the law of inertia. Inertia is the tendency of an object to remain at rest or remain in motion. When the roller coaster stops, watch the kids. They bend over the front of the car. Inertia makes them keep going, even though the roller coaster is stopped. Give this one a try. These pennies have inertia. What will happen when you knock the card away? If you flick it hard enough, the car flies away and the pennies fall into the beaker. Let's try that again. Because the pennies have mass, they have inertia. They have a tendency to stay in one place. But once the card's gone, there is nothing to hold them up. The forces are unbalanced and they fall into the beaker. So check this out. All you need are some coins and a white or a clear balloon. Now stuff a penny into the balloon. You may have to work at it a bit to get it to go in. Try to use a new penny. Old rough ones may pop the balloon. Blow up the balloon and move it in a tight circle until the penny stands up on its side and starts to roll around the inside of the balloon. It takes a little practice, but you can do it. Once you get the penny going, it doesn't want to stop. It has inertia. It'll keep rolling until its motion is changed by an unbalanced force. In this case, the forces of gravity and rolling friction are causing the penny to slow and eventually stop. So let's try a penny and a nickel. Which one will roll the longest? Make a prediction. You may have to work at it a bit sometimes, but there it goes. So first the penny falls. The nickel is still rolling. The nickel has more mass, so it has more inertia. Try whatever you want. This time I have 3 pennies inside the balloon. If they fit, you could try any type of coin you want. See how many you can do at once. If you have some marbles, try those. What else would work? This time I have a nickel and a dime, but don't be surprised if this happens a time or two. So why should you care about inertia? Well, let's go for a car ride. Now that you know about Newton's first law of motion, what will happen to the egg when it stops suddenly at the bottom of the hill? For more information about Newton's first law of motion, go to howaboutscience.com.